So here's y equals cosine x, and it starts at 1. Comes down, goes up, so we'll bring it over this way. Okay, so there's our cosine wave. What's it going to look like when we rotate it over the line y equals x?
Same thing.
Yeah, pretty much the same thing. This point's going to go where?
To the x-axis.
Yeah. Yeah. It's going to be over here like this. Remember, we can always do inverses by saying, well, what's that distance there? Well, I'll just make that distance go on the other side of the line here. So it's actually over here. So if you take a look, actually, let me show you what I like doing. I always used to have trouble. I showed you I always used to have trouble doing this. So here's a nice trick. Let's take our piece of paper. We'll graph it on this. This is my quick and dirty way, since I always used to have trouble with this when I was your age. There's my cosine wave, right? So I'll put my line on. Here's my line y equals x. Here's my line y equals x. So now I'm going to rotate over that line. Can you see what it looks like through the back? Goes here. That's your inverse. That's a quick and dirty trick for rotating and finding inverses on the test. So it looks like this on the back side. Of course, you need a dark pen to make it work well. That's what it ends up looking like when I flipped it. So I can take that over here and say, oh, looks like this. So it's going like that. So my inverse function is my original cosine. There's my inverse. This is y equals cosine inverse of x. Actually, keep boogering that. Just like that.
Okay, so now where do you take it?
Get your thinking ahead. So the question is this a function? No. Do I need to make it a function? Sure. So the question is, where do I break it? Well, when we did sine, we went from peak to peak, right?
Yeah.
Because of going from peak to peak, that got us all of the values in between. So if we look at this, what does peak to peak look like? Well, although the diagram isn't great, here's one peak right here. So I have a choice. I can either take this, but then all of these values are negative. Or I can go from this peak to this peak here, in which case all of these values are positive. And so this is the one that we usually use. So on my calculator, if I want cosine inverse, my values are going to be between what and what? We're going from here to here.
0 and 180.
Precisely. From 0 to 180, because look at the unit circle. In this area, this gives me my positive x values. This area over here, quadrant 2, gives me my negative x values. So far, so good? So if you put cosine inverse in your calculator, you're always going to have 0 less than or equal to x less than or equal to 180 degrees. Always. Does that make sense? Great. The other thing you should know is that sometimes they don't call the function sine inverse because people get confused. People look at this sometimes, and instead of thinking, oh, the inverse of the sine function, sometimes they look at this and they think what? They think cosecant. They think you're taking 1 over sine. Whenever you have a negative 1 power next to the name of a function, you're looking at the inverse function. You're not looking at its reciprocal. So some textbooks don't like writing this because they think it's confusing. And so sometimes you'll see instead of sine inverse, they'll call this the arc sine. And sometimes they'll call this the arc cosine, so that there's no confusion between the two of them. Questions? Be a good place to hit that.